Morning, everybody. Happy Monday. It's a little rainy out today, but that's all right. Let's get into this morning work. Week 29, Monday. So, week 29, Monday, number 1 and 2 has that weird typo thingy. Quick, easy way to get rid of it. Get a white marker or white pen using your whatever app you're using, and then just write over it like this and make it disappear. And then switch colors back to whatever color you're writing in. I'm going to write in a blue. I like this dark blue that I made. And now I have a space to make my number line, which that's way too thick, but you get the idea. I'm going to go back to my thinner one. And now I can work a little more clearly. All right, let's get into it. Now, I published a video a couple days ago on how to draw a box plot and read a box plot. So if you're not sure how to do these two things, I would recommend going to watch that video. That'll break it down much better than I'm about to, because I'm just going to hit it. Our minimum is 2. Our maximum is 9. So I'm going to go from 0 to 10, because 0 to 10 on my number line will include all the numbers I need and not leave me too much space. So after dividing it in half, I'm then just going to divide each half into fifths as best as I can. And that's going to be my 5 right there. And so this is my 1, my 2, my 3, my 4. That's supposed to be 3. 6, 7, 8, and 9. So now I'm going to plot my 2, my minimum, above the 2 as a dot. I'm going to plot my 9, my maximum, above the 9 as a dot. And the same horizontal, I want it to kind of be straight across right here, straight across. And now my quartiles are going to be lines that kind of go, the middle of the line would go right to the dot, right? If I want it to look nice, as best as I can. My median is 5, that's my quartile 2. And then my quartile 3 is 7. Now I draw a box around my quartiles, and then I connect my dots. And there's my box and whisker plot. Sometimes they call it box and whisker plot. And these are the little whiskers that come off. So the number line's based off of including all the numbers. So you look at your minimum and your maximum, and then you try and find a nice rounded number before and after. And then you throw in your minimum, maximum dots, put in your quartiles, box your quartiles, then draw the line to your minimum and maximum. Let's check out number 2. So in reading this question, I think I've figured out that those typos are supposed to be number lines. And anyway, so I'm just going to draw a number line underneath this like that, and it wants me to place 0 and 5 on the number line, so the box plot's correct. Now quartile 2 is 5, so that would be this line. So here is going to be my 5. My minimum is 1, right? So this would be 1, and I'm going to make this 0. And so then I have, looking at 2, 3, and 4, I'm going to have to put 0 a little bit closer, and then just use my white to erase all the rest of the stuff here, because you want it evenly distributed. You don't want like a big space between 0 and 1 and then tiny spaces between everything else. So I'm going to try and just make equal spaces. Now quartile 3 is at 9, so that should be about 9. 6, 7, 8, yep, there's 9. And then I would say that the maximum is 10, yep. And so my number line actually matches up with it pretty well if I do this right. If for some reason my number line goes to 13, that's fine. Who cares? And then quartile 1 would be at 4. And you can see they line up pretty well, right? The 4, 5, 9, and 10. And they're evenly distributed as best as you can as a human being, not a computer. But they're all centimeter apart or so, or depending on how much you zoom, of course. Like now, look how far apart they are. Ooh. All right, here we go. Okay, so fun looking number 3. I'll also tell you that I've also published a video on finding percents of amounts, which bounces off of percents conversions to decimals, as well as fractions versus decimals. Those 3 videos should make all of this kind of questions. All these make sense. But percents of amounts is specifically about this. So 18% is 60% of something. So there's a couple options here, but I'm just going to skip right to writing not 18%, $18. $18 is my whole number. And then 60% is going to be 0.6. But what I'm going to do is, since I'm looking for the total, I don't know the original price of the shirt. 60% and 18 are the parts. To find the total, if I'm using the decimal, I'm actually going to be dividing by the decimal. When you divide by a decimal, your whole number gets bigger. So now I just go through how I know to divide by decimals, which is another video I've published. I move the decimal over once. And so now I've got 180 divided by 6. 6 goes into 18 three times with a 0. So the original price was $30. And yet another video I've published in the last week or so is Interquartile Range. And actually, I think that's the same one. I have two on Interquartile Range. One of them specifically just about it. The other one's about box plots and Interquartile Range. But those all are pretty simple concepts. As far as range, we should already know, right? Range is greatest minus smallest. It's a distance between things. That's what the word range means. So interquartile, IQR, interquartile range, simply means what's the range within the quartiles. So you're going to take your biggest quartile, quartile 3, and you're going to subtract your smallest quartile, which is quartile 1. That's all interquartile range is. And so 18 minus 11 is 7. So again, I just keep a picture of the histogram and I put it into my document here for you to see. And the question is, what interval, right? These are the intervals, 121 to 125, 126 to 130, etc. Has the greatest number of girls? Well, frequency is the number of girls, right? The frequency is how many fit into this category. 3 fit in this category, so that's 3 girls at 121 to 125 centimeters tall, right? We had a big range of distance of lengths, heights, sorry. We had a big range of heights from 121 all the way to 145. And to make a bar graph of all that would be a lot. So you can combine them into groups and make less bars, right? And obviously this bar has the most girls at 14. So the answer would be 136 to 140 centimeters, because it tells you that it's centimeters right there. So Module 5 in Eureka Math talks about area of different figures, breaking away from just length times width for squares and rectangles, and it brings in trapezoids and triangles and parallelograms, and I've got lots of videos on that too. So what we're going to do with this trapezoid is we're going to make an imaginary line. This line does not really exist. They drew this for you to help you, and you'll notice what they did is they made it 90 degrees or a right angle from the base or the bottom all the way to the top, which would be a height, right? So we have a rectangle that has been created and a triangle that are connected, right, theoretically, to make the actual figure the trapezoid. So the actual figure is the solid line. The dotted line is just a drawn-in fake line, imaginary line, to separate it into two shapes. And we're going to find the area of the rectangle and the area of the triangle, then combine those two to find the total. So the rectangle is 2 by 3, and I know this is 3 because this is 3, and opposite sides of a rectangle are the same. And so 2 times 3 is going to be 6 inches squared. Now, area of triangles, another video to go back and watch if you don't remember how to do that, but we're going to do base times height divided by 2, or 1/2 base times height. So 1 is our base, 3 is our height, that's 3. We're going to divide that by 2, which is 1.5, right? And so now we've got 1.5 plus our rectangle, 6. So the total area is going to be 7.5 inches squared. And 7.5 inches squared is the same thing. So I don't really know what this is over here, but feel free to use your white and get rid of it. But again, we have 2 triangles. And here's the fun thing. When you have 2 identical triangles, since the triangle formula involves dividing by 2, but then you're going to double it again, you just don't divide by 2. And you have the total of both triangles. And then we also need to do 2 by 2. And obviously it's not drawn to scale, because this does not look the same length as this. But a lot of times the figures that they draw will say, at least in Eureka Math, not drawn to scale. That means this can be 2 and this can be 2, and they don't have to look the same. We're going to go by the numbers. So the rectangle is going to be 4 inches squared because it's just 2 times 2. And then each triangle is going to actually just be 1, right? Because 1 times 2 divided by 2. But since we're doubling that, right, 1 and 1, that's 2, we could theoretically just not. So we have 2 plus 4, which is 6 inches squared for our area. Okay, so for number 8, in order to get y, we have to double x and then subtract 1. That's what this says right here. So let's double the 3, which is 6. 3 times 2 is 6. Minus 1 is 5. So y would be 5. Let's double the 2, which is 4, and take 1 away. That's 3. Double the 1, which is 2. And then take 1 away, which is 1. Double 0, which is 0. Take 1 away is negative 1. Double negative 1 is going to be negative 2. And then you take 1 away, you're at negative 3. All right, I think I have some other videos on this, but this may go into some of the module lessons. So if you have questions on this, just message me on Schoology. So I'll show you a couple ways on number 9, finding the area. We know a square has to have equal sides, so they only gave us one side, which is fine, because we know if it's a square that this is also 3.5 centimeters. So if you go fraction-wise, just put them as mixed numbers. 2 times 3 is 6, plus 1 is 7, so it's 7 halves times 7 halves, which is 49 fourths when you divide and simplify. 12 times 4 is 48, and then you have 1 left over, fourth, and that is centimeters squared. Or you could just do 3.5, because remember, 1/2 is 0.5 times 3.5, and when you multiply that together, you're going to get 12.25 centimeters squared. And I have another video on multiplying decimals and fractions, so check those out if you need to. And lastly, for the distributive property, what they're looking for here is that you're distributing the 6 to the 4 at 6 times 4, and then you can add 6 times the 3. So remember, the distributive property says you can distribute what's outside the parentheses, touching it, right, which is 6 times, to each item in the parentheses. And then, obviously, the plus. We can't do 6 times plus, so the plus just gets brought down. So 24 plus 18 is 42. Now, if you just do 4 plus 3, you get 7, and 7 times 6 is 42. So both ways will work and give you the same answer. They just want you to see that you know the distributive property. Well, there you have it. If you have any questions, message me on Schoology or leave a comment on the video. Also, I referenced a lot of other videos, so for those who can't access YouTube, they're on my Edpuzzle page, class code NIMZAGO, NIMZAGO. So you just go to edpuzzle.com, be a student, and join that class, and you can see all the videos on Edpuzzle from a device that won't let you watch YouTube. So anyway, if you have any questions, go view those or let me know. All right, talk to you later.